Production Activity Control, or PAC, is the area of our operation which is tasked with making things happen. The MRP calculation provides a schedule for what jobs need to be released to the shop floor in order to meet the demand plan. However, there are so many things that can happen on the shop floor which can influence the delivery of the schedule. Such things could include a lack of resources due to absenteeism or a machine breakdown, or too much scrap resulting in a lack of raw materials, for example. As with all other levels in the planning hierarchy, the planning function in PAC is just as important. Before releasing scheduled orders to the shop floor, PAC must ensure that all tooling, drawings, routines, materials and capacity will be available to meet the planned schedule. In essence, PAC concerns itself with three activities: planning, implementation, and control. PAC planning needs to know what products need to be made, when they are due, and how many are needed. Breaking this down into detail means knowing the duration of each operation involved in production, what resources are required, and what materials are needed from the warehouse. PAC implements the plan by managing priorities. All the planning process which happened before should have provided a stable production schedule. However, the actual daily scheduling is impacted by unforeseen events, and so priority planning becomes an essential element of PAC. The factory may have 20 jobs scheduled to start on a particular day. Priority plans put them in the right sequence according to the priority of the job and their expected due date. Be sure to read all about the priority rules in your practitioner's guide. Now, PAC monitors and controls the flow of work through each work center, looking for any incidents that could delay the schedule. This is known as shop floor control, or FSC. FSC looks at scheduled start dates and end dates and makes sure that capacity and materials are available to ensure a smooth flow. Monitoring the queue in front of each work center helps to see where bottlenecks operations are. Mass production, or flow shops, are designed around the production of specific products, such as motor vehicles. If anything goes wrong on a production line, everything comes to a standstill. In a job shop environment, however, the production facility has a functional design, meaning that different work centers can work independently, and each work center is typically allocated the same type of work. From a shop floor control point of view, the flow shop is designed to be synchronized, and therefore material is issued to the production line as and when it is needed. The product being made moves along a production line, and the skilled workers are placed at points on the production line. In the job shop environment, the semi-finished materials or works orders physically move from one work center to another. Because this flow is not synchronized like the production line, there is much more opportunity for delays to take place. When we look at the operations of a works order, there are elements such as move time, setup time, queue time, wait time, and breakdown time. Controlling and monitoring the rate of work going into and out of a work center and the factory as a whole is known as input-output control. The input rate is controlled by the release of orders to the shop floor. If the rate of input is increased, queue, work in progress, and lead times increase. The output rate is controlled by increasing or decreasing the capacity of the work center. PAC relies heavily on accurate data. This is accurate data in the form of inventory levels, BOM structures, routing files, and work center master files. We should be aiming to achieve 100% accuracy in each of these records to ensure that we ultimately meet the objectives of PAC. The objectives of PAC are to deliver the required quantity and quality of finished products on the expected due date. This is done by focusing on the detail of every operation that occurs in our production facility.